We're starting our first panel. The panel is about AI in the open world. So, we are going to discuss what we mean by, or what we understand by AI in the open world. But I just want to talk briefly about, what Eric has been doing in this space. So this topic is really, in my opinion, a prominent topic in Eric's mind. Actually, we've been talking the other day in our group meeting, Adaptive Systems and Interaction group meeting, about after the reorganizations and the group splitting, what does our team stand for? And we were thinking, the connecting thread is we all care about AI in the open world. So in 2008, when Eric was the AAAI president, his presidential address talk's title was AI in the open world. And then way before people started talking about AI and its influences in the world and people in 2008, one of his presidential initiatives was the Asilomar meeting on long-term features of AI, where he brought together prominent names in AI, where they actually discussed opportunities and challenges for long-term features. And then in 2014, Eric and Mary started an initiative at Stanford, the 100-year study of artificial intelligence, which I was also lucky to be a part of for the first study panel, where it is really a 100-year or longer study of influences of AI in people and society. Mainly, I think that you realize that this is a much longer topic than just a meeting in Asilomar. Since then, these topics, both AI's influence in the world, in society, issues around bias, fairness, transparency, explainability, reliability, safety, all of these topics became very prominent in our daily discourse, in our research community. And Eric is currently chairing a big initiative at Microsoft on AI and ethics, and he also is a founding member of and co-chair of Partnership on AI on these issues. So this is kind of the framing about Eric's position in this topic, but now we are just going to have fun as friends talking about AI in the open world. So just to start things up, I'm just going to ask, please introduce yourself in case people may not know, and also tell us what you think of, what is AI in the open world? How is it different than the other AI, if there's another AI? And what are the major challenges you see our community facing in this topic in the few years to come? Cathy.
All right, so I guess I'll start. My name is Cathy, and I'm a graduating PhD student at UC Berkeley. I am going to spend the next year here as a postdoc with MSR before starting a faculty position at MIT. And a lot of my thesis work has been about integrating AI into these large-scale societal urban systems, in particular transportation. And it's been a really amazing journey, including the work done here on ride sharing, to see how connected many of the pieces are, and how general, how different aspects of this problem touch on the techniques and the models and the application domains. And so to me, AI in the open world, I don't know if this is the intent, and I'm curious of everyone's opinion, but I feel that there's a distinction between the open world and the real world. And to me, the open world, I really like this term because having heard it for the first time with the panel, actually, because it seems to imply that it's not just a distinction between the real world and the not real world. It's not just like theory and practice, but there's a whole continuum of important problems that need to be looked at. That studies, intermediate studies that are maybe towards the real world, everything along the spectrum is really important for us to study. And there are challenges along this entire spectrum, and all of the work along the spectrum has to be valued. So I have no idea if that was the intent, but that's what I got from this, and I really like it. And so I think some of the challenges that I think are important in this area is it is almost everything, almost all of like how to build AI into the open world. Like almost all of it, I think, is unknown. We don't really have a good understanding of what happens when we introduce automation, even in the simplest cases. One of my favorite examples, which I can get into if anyone doesn't know about, is the automation of the elevator in Building 99, and how like immediately it didn't work. I don't know. I can go into it, but I want to move on.
I think you should say a few sentences about it.
Okay, so this project, day one of my internship, maybe this day one of my internship, Eric mentions that I need to talk to Dan Bohas about this elevator. That there are a lot of interesting problems. So this elevator, there's a camera right underneath, right in front of the first floor of 99, and it basically tracks trajectories of people walking past the elevator to the cafeteria or into the elevator, and tries to classify which one it is. If you're walking towards the elevator, then you should hit the elevator button door, so by the time you get to the elevator, the door opens, and it's great. Everyone's lives are much better. And they collected like 4 weeks of data and did this classification, and then deployed the system, and everything's great. Everyone's like saving a bunch of time and energy, and then suddenly people think, oh, I don't have to go hit the elevator button. So they walk up to the elevator and they stop by the third door, the door closest to the entrance, which is an out-of-distribution trajectory, and the learned classifier has no idea what to do, and so the system breaks down. And this is an example which I really like because it's like very simple, and you think it should just work because it's an elevator, but we deploy the system, and we don't know what humans, how this will affect the humans, and this is true for like any AI system and any integration of automation. So that's also one of my first interactions with Eric.
And this is actually getting to Evan Lawson's talk in the morning, where he was talking about like the drug interactions, and when you make a treatment decision,
yes,
that is
exactly.
changing the distribution.
Yeah.
So that was for the drugs, and now you're talking about elevators, and the same problems are coming up. I actually like this, giving an example of open world. So let's also continue with that today. You also give an example of AI in the open world.
Yeah, thank you. My name is Debadeepta. I'm a researcher in Eric's group, ASI. So my background is actually at the intersection of robotics and machine learning. So this is, and thank you for that amazing example, because much of my research, I happen finding myself trying to close the gap between perception and planning. And this is a big robotics holy grail problem where often controls, optimal control, planning, they all assume that the world is perfect, and the world is perfectly perceived with no uncertainties and no errors. Everything is happening at the speed of light, instantaneous, and all we have to do is take action in that perfect world. And this problem is perception people's problem. And then perception people are like, no, the world will never be perfect. This is a hard problem. So you got to deal with all the imperfect data that's coming out of perception systems, right? And there's this big gap between both of these systems, both of these modules that usually gets deployed in almost any robot out there, or even in a system like the one Cathy was referring to, where you have a perception system which is obviously imperfect, and there's a decision-making system, and they have to like live together and act together, right, and understand each other. And this is where I find myself spending a lot of my cycles thinking, and almost every project I do has this theme. For example, while during my PhD years, we were doing autonomous drone navigation through forests, low to the ground, and there was this big push on let's use learning-based methods. And one of this and one of the bigger disadvantages of using learning-based methods is as soon as you encounter anything which is out of code distribution, in example, the system just degrades drastically instead of doing good fallback. And which is and we found ourselves reverting back to multi-view geometry, which are the laws of physics, and leveraging that. And I think a big problem or a hot topic right now is how to fuse machine learning, which tends to work in this on average expected case, and all our theory is very well understood, mostly in this on average expected setting, to high probability confidence settings, which you really need in order to make open world AI succeed. So
You haven't given an example?
no, drones.
Okay, drones, robots.
Okay, I will start with an example and then introduce myself. But when I had just moved to Seattle, everyone told me, oh, you know, you have to go visit Cary Park. It's the best view of the city. And so I went, and it was a beautiful summer day. I was lucky enough to have a perfect view of Mount Rainier. And, you know, so was half of Seattle, so it was a pretty crowded space there. And there was someone actually trying to take pictures of this beautiful scene with a autonomous drone. And so there was this drone that was hovering above this entire crowd. And people are watching, some people notice the drone starts to make a noise, and suddenly this drone just like starts dropping out of the air, swerving towards the crowd of people. And you can see everyone going, and stepping back. And when often I think about AI in the open world, this is a picture that naturally comes to mind when we think about safety and stability of these kinds of autonomous systems that are in the world. We think about, oh, you know, robots gone wild. In some variation or another, this is the variation we're seeing today. So with this context, let me introduce myself. This is how I used to think about AI in the open world, or this phrase AI in the open world. If someone had asked me, you know, 4 years ago, what I thought about AI in the open world, I would have probably thought of some example like of the robots gone wild variety. My background is largely theoretical, and my PhD work was a lot of stability analysis for control theory. But after being at MSR is when I started to realize that there's actually many different perspectives, and AI and thinking of this kind of safety and stability of robotic and control devices is one small perspective and one small part of AI in the open world. So my name is Gireeja Ranade. I was a postdoc here at MSR for 2 years, and then until like basically last week. It's really awkward to say. The tense seems really odd, but I was a researcher in the ASI group with Eric.
Oh, you're still with us.
Yeah.
Yeah, I have another comment about that, but I will save it. And I just started actually as a professor at Berkeley as of last week. I taught my first lecture yesterday.
2,000 students.
Yes. But what I wanted to say is that, you know, as I've been at MSR and under this influence of the ASI family, which I want to come back to, I found my ideas around AI growing and expanding to more recently thinking very closely not about these physical world AI applications, but a lot more about the unseen, maybe psychological implications of AI technologies. And one of the kind of most significant experiences of my time at MSR, and I'll talk more about this in a bit, has been this collaboration with Eric and Adam and Bessa and Mickey, who used to be here, as well as a couple of others, Alex Stanger, on trying to understand the impact of misinformation in the context of political elections, and in particular, very recently, the influence of the Russian advertisements, Russian interference in the election. This brings up a lot of interesting questions about, you know, what are automated recommendation engines doing to our thinking? And in particular, these investigations around the Russian advertisements have been very recently very interesting.
And I am the Russian interference. in this team.
So the question is, что делало агентство интернет-исследований?
Мы не даем комментарий по нашим секретным операциям. On a more serious note, my name is, my operative name is Andrey Kolobov, and I joined Eric's team 5 years ago with the intention to work on sequential decision making under uncertainty. Back when I joined, I, frankly speaking, was not making much of a distinction between AI for the open world and just simply AI, because I thought what I was working on is AI for the open world. How do you get, what is the practical distinction between them? Well, I thought, you take an algorithm that you came up with, you put it in a real system, and there you go. That's AI for the open world. However, when I started trying to actually use techniques that I was aware of, and also those that I came up with myself in collaboration with Eric, the interns that we worked with together, Chris Lynn, for instance, trying to apply them in Microsoft's products, I ran into some issues that I was not aware of, and I started thinking, so what exactly is it that distinguishes AI for the open world from AI for the lab? And after thinking about it and reading especially Eric's works on meta reasoning and more generally on bounded rationality, I kind of came to the realization that at least to me, the distinguishing capability of an AI capable of operating in the open world is the ability to deal with bounds, to deal with limitations and bounds. And some of these bounds we can formalize quite easily. It's the bounds of the kind, well, you have to achieve this objective by this specific time. You cannot go here. You cannot do this. But in general, these constraints have, some of these constraints have much more subtle flavor. And AI systems that are designed in the lab don't always take them into account. One of such constraints are the computational constraints. AI systems operating in the real world do not have infinite computational resources usually. They do not have an infinite number of attempts at learning something. They do not have an infinite number of attempts at trying something, because by trying something they change the world around them and they can't go back. Also as a result, they cannot expect to do well in expectation, because they will never get a chance to do well in expectation. Sometimes they get to try the policy they came up with once or twice or maybe 3 times, and that's all they have. If they did well, good. If not, well, too bad. And the 2 projects that I'm working on that are exploring these topics in more detail is big crawling. So web search engines have to collect information from the web, and for that they have to download pages from around the web. And the question is how to do this so as to maintain as fresh of a cache of the web's pages and index as possible, given that you have constraints on the bandwidth. You can only re-download so many pages per day. And also the hosts from which you're trying to get these pages have their own constraints, because they don't want search engines to steal too big a fraction of their bandwidth. And another project which is it's more of a testbed project, in the sense that the techniques that are being developed there are maybe not. It is not something that Microsoft, let's say, is interested in investing in, but a project that hopefully will yield techniques that will be applicable elsewhere is the autonomous soaring project, where we're trying to build a glider that is supposed to go from point A to point B without very long distances, without using any motor power, simply relying on the forces of nature. There are many aspects to this project besides the boundedness of the computational resources on board the sailplane. It also does not necessarily does not have perfect knowledge about the weather. It does not have perfect knowledge about the weather phenomena it's going to encounter along the way. And it also has to learn as it's going along. And in many situations, it will only get 1 or 2 encounters with a certain phenomenon to understand how to behave in a certain situation. And with that, I would like to hand over to
I'm actually glad that Hima is last. She's coming after you, because one thing we haven't touched so far very much is the human, right? Human in this equation. So Hima, can you talk a little bit about how you see the human in this open world?
Yeah. Hi everyone, my name is Hima Lakkaraju. I'm currently a PhD student at Stanford, and I'm almost finishing up. So my association with MSR, with Eric, with AJ, and others in the ASI group has been through various visits and internships and ongoing collaborative projects. So let me just talk a little bit about what AI in the open world means to me, and also how that sort of connects to my thesis dissertation. So when I think of AI in the open world, and lots of great perspectives, so to me it's basically about the integration or kind of bridging the gap between, as Andrey rightly said, the AI algorithms in the lab and the AI in practice, right? So I work a lot with judicial decision making and medical decision making, where the goal is whatever algorithms you develop, you need to kind of build them or kind of like make them in such a way that a judge is comfortable using them, for instance. So there is always a human who is going to use these systems, who is going to rely on these systems. So how do we bridge the gap, or how do we take all these algorithms that we are building in the labs to people who are like the judges or doctors, who are basically the decision makers who rely on the tools that we are developing? And under this umbrella, of course, you can imagine a lot of things, basically, and others have highlighted a huge chunk of those. But a lot of work that I did focuses on things like, how can I enable the decision maker to trust the algorithm that I'm building? And of course, I'm kind of touching upon the issue of interpretability and kind of enabling the human decision maker to understand what's going on underneath the hood for the algorithms that we are designing. Beyond that, of course, you could also think of issues like fairness, especially in contexts like judicial decision making. You want to make sure that the algorithms that you're building are not biased according to race or gender or other factors. And you can also think of other issues which others have brought up, like reliability, which is the models that you have trained for probably one court in a state might not be applicable to some other jurisdiction. So when you think of AI in the open world, all these issues of how you are bringing these systems to the real world and what are the gaps that exist in between, which include things like making the models more interpretable, making them more reliable, or at least understanding what are the blind spots of these models, and making these models more fair. To me, all of these topics fall into that particular notion of AI in the open world. And my thesis and my dissertation has been a lot about these topics. And with Eric and AJ and folks at the ASI group, I've been working on this active research area of how do we sort of diagnose the blind spots of predictive models, where the model itself thinks it's very confident about some of the predictions it's making, but is actually completely messing up. So how do we detect those beforehand, before we even deploy models? So that's one example of like a subdirection of AI in the open world.
Great, thank you. We already have very little time left for the panel, so I'm gonna throw out a few questions, and feel free to answer whichever one you find more interesting or you find more pleasing, because this is, although Eric doesn't want it this way, this is still an event to celebrate our collaborations with Eric. So if you want to say things about how Eric influenced your thinking in this space, please feel free to do so. I also wonder about your thoughts about, like, how are we going to really build successful AI systems for the open world? How do we bridge this gap between all of our thinking from a research space and the real work that's going on in industry and companies? So just some final thoughts around those. I know I throw out big problems, but some remarks, whichever way you want to go through them. And we don't have to start with Cathy this time. Day, you wanna take your first
sure.
pass?
Like one of the things that always caught me still catches me by surprise is that big complicated systems are being built everywhere, right? Like, we are a company like, whose bread and butter is building big complicated systems and selling them as a service and different shapes. And be it robots, be it software services, or like, or cloud services, we are always building systems nominally. And this is a quote I picked up from from Eric's paper from 1989. And where we are always building, engineers are getting together and scientists are getting together and building the systems, assuming that, look, let's just build the system, let's get it to work first, and then we'll figure out how much compute we have, and let's see what's the best we can do. But there's always this, like, meta reasoning which is left out, which is What about anytime decision making? What do you do how does your system degrade when your compute resources are getting consumed by somebody else and you have much lesser compute time? Or I will give an example this time, is when, imagine you're a self-driving car system and you're driving down the road and you have a particular decision making cycle, and let's say you move at every 30 milliseconds, you're making a particular decision of what your accelerator steering should be. But the moment, let's say and if you drive on 405 around here, this is an everyday occurrence, somebody's merging into the lane or taking an exit without really looking, and that creates an emergent situation where where the car should react very fast, right? Like, so you have this emergency maneuver you have to probably decide to take or not take in probably milliseconds. You have milliseconds of margin left, and this is where systems have to learn where to speed up, learn where to slow down to buy themselves compute time, learn to anticipate, and do all of this under bounded computation. If you're a self-driving car, you have the computer you have. You don't have the luxury, especially under these emergent conditions, to invoke the cloud and wait for a better decision. So these are all things which I believe should be built into the design process itself. And this is something that Eric heavily has influenced me from many, many papers, going back all the way to 1987, 88, and even now, some of the work that I've been doing, including how to make anytime neural networks anytime in nature, budgeted prediction, as well as searching for more cost-efficient neural networks, which have anytime built into-ness, are examples of all that influence, and meta-reasoning in software pipelines.
Let's go faster.
Okay. I promised I'd say something about the ASI family. So when I first started at MSR, I heard this phrase being talked about every now and then. Oh yeah, the ASI family meeting. Or I was like, is this a company?
It's a cult.
It was really, I didn't quite understand it, and I just chalked it up to, okay, something different. But as I've been here over the years, and especially being at this event today, I'm realizing what a powerful concept that is, and how true that phrase is in terms of describing the culture that I was lucky enough to be a part of. And I feel like when people ask me what my experience at MSR was like, I often say, I think I won the postdoc lottery. And the reason for this is that, in my early meetings with Eric, I remember he'd be like, oh, you're doing very interesting stuff. Yeah, do whatever you want. Talk to me, talk to people that you want to talk to, learn about stuff you want to learn about. And so there was this freedom that you get basically from a family to explore things and do what you want. But at the same time, there was a tremendous amount of support to kind of push you forward and help you grow. Through meetings that Eric would organize, for example, with the Partnership on AI or at these Origins projects. This is what actually allowed me to really grow this area of interest in terms of AI and society and the open world. I remember when, soon after the 2016 election, me and Mickey, who was another postdoc in the theory group, I was kind of, I'll admit, upset about the election. I was really wondering about, what's happening with the news. I hadn't talked to Andrey yet. And I did what I could do as a theorist, was I was like, okay, I'm going to make a model. So I wrote a model of how a rumor could spread from one node in the network to another. I wrote a little bit of a simulation. And then Mickey and I actually went to Eric. I remember it very clearly of Eric, we should do something about this. And here's a model. And look, our simulations predict that if we applied this intervention, this could happen. Eric's like, wait, this is really interesting. And I've been thinking about this. And what we should do is we should look at data. And immediately, 2 days later, he basically was like, this is the ASI family. He introduced me to Adam. And basically, this has led to one of the most fruitful collaborations that I have had at MSR. It's completely a new research area for me. And thanks to the family, thanks to people like Adam and Bessa and Eric, who have helped me grow from my comfort zone in theory to some of these broader perspectives. And I could say a lot more, but I will stop here with a thank you, just in the interest of time. But thank you.
I'll just be brief. I think no matter how we go about building AI for the open world, at some point we'll have to take the risk of actually unleashing it into the open world. And I'm talking about not just risk in the sense that some of our ideas, it will turn out that maybe some of our ideas have not worked out, and maybe we have wasted time. No, I mean, I'm talking about the risk of these systems actually doing something unexpected in the real world, something that maybe the real world might not necessarily like. And in this, given this, I think it's especially important that to basically have the backing, to have the support to take risks like this. And what I particularly appreciate about MSR, and it is really thanks to Eric, that I feel the confidence, I feel the backing that I would need to take such risks.
Okay, so I think let me talk a little bit about my experience with, of course, Eric and the ASI group, just like others. So one of the main things that I sort of took away from my internships here and my collaborations here is, of course, the problems of, whether it was fairness or interpretability, all of these were interesting to the machine learning community, but from an algorithmic perspective a lot of times. And I think the ASI group and Eric in particular taught me to emphasize there's a human in this loop. So finally we are doing all this for a human. So it's important to keep that human in mind. So basically they really taught me, or they really encouraged me to emphasize on the human factor side of it and not to shy away from that. Thinking maybe it's not too algorithmic or it's not too theoretical, it doesn't matter, but at the end of the day, our end goal is that these systems reach humans, so we need to keep that aspect very strongly in mind. And I think today when I do research projects, that thought process has definitely been a very big influence, and I'm super grateful to the ASI group and particularly to Eric for that.
We'll finish with you, Cathy. Some very, very quick.
Yeah, a brief comment is one takeaway that I already have from just the first part of today's program is that it's been remarkable. Every talk that I've seen this morning, I feel like I've already become familiar with your work because Eric has already shared it through conversations with a lot of energy. And this tells me something really special, which is that all of this work is very different. There is a common theme, but it's very different. Eric does not hold back and think, oh, you're interested in why, so I'm only going to tell you about why things. And I feel that this goes a long way to actually expressing that multiple aspects of a problem of a system matter. And I was really happy to see, I think this is from James's talk, this paper on mixed valued user interfaces, that it comes across in individual papers of Eric's as well, and in work on emphasizing people and algorithms and the systems. And I think that one of the challenges that we will face in deploying these systems in the open world is that all of these factors are really important, people and the algorithms, and it's not about which is more important, which kind of researcher are you. All of these, if any of these factors is missing, then the system won't work. And I think that's something that I think is really cool that Eric seems to convey this in his research and his daily interactions with people. And that's one of the takeaways I already have from the first part of this event.
And I'm going to take a minute just to say thanks to Eric, because I'm not going to have another opportunity today. I think I did my first internship 11 years ago, and what I understood in these 11 years is that what makes a place great is the people, nothing else. And when people really like each other, like being together, the ASI family, everybody is happy and they don't want to leave. And thank you, Eric, for giving us the ASI family, where we are so far away from our homes, real homes. And thank you for making it so joyful to come to work every day. So I'll just finish with that, and we are going to continue with our session on health, wellness, and AI.